Lesson 7-3 Practice Tangent Lines. Question 1. Line BD is tangent to a circle with diameter AB. Complete the following to explain why the measure of angle BCA must equal the measure of ABD. The measures must be equal because they are both right angles. Angle BCA is a right angle because it is the blank angle of a diameter. It is a inscribed angle of the diameter. So ACB, is that right? Or they call it BCA, same thing, is inscribed angle of the diameter. Angle ABD, that's using the tangent line, is a right angle because a tangent line to a circle is always blank to the radius drawn to the point of tangency. Well, it's always perpendicular, 90-degree angle. Question 2. Line AC is perpendicular to the circle centered at O with radius 1 unit. The length of AC is 1.5 units. Which of the following is the length of segment AB? To find segment AB, we're going to find the measure of this hypotenuse of this right triangle and subtract the radius. So the measure of the hypotenuse would be the small leg, which is the radius, 1 squared, plus b squared, the long leg of the right triangle is 1.5 plus 1.5 squared. And we would take the square root of that, the square root of 3.25. And finally, we would subtract the radius, which is 1. That would be segment BO. We would subtract that. So it would be the square root of 3.25 minus 1. Negative 1 plus the square root of 3.25. Question 3. Line PD is tangent to a circle of radius 1 inch centered at O. The length of PD is 1.2 inches. The length of AB is 1.7 inches. Which point on the circle is closest to point P? Well, it would have to be either B or C. To calculate B, we would find the hypotenuse of this large right triangle and subtract 1.7, right? To find distance BP. The short leg is 1.2, so 1.2 squared. Well, again, it would be the square root. To find side C, you have to take the square root. So the square root of 1.2 squared, and then the long leg would be the diameter of this circle, AD, and if the radius is 1, the diameter is 2. And we would take the square root of that, obviously, and we are going to subtract 1.7. I think I said 1.7. Yeah, that we're going to subtract the chord AB. To find the distance CP, we would do the same thing with the smaller triangle. Its shorter leg is 1, so we take the square root of 1 squared plus its longer leg. Its longer leg is 1.2. And we would have to subtract the radius, segment OC or CO, which is 1. You can see that is a smaller distance. CP is a smaller distance, so point C is closer. Question 4. The arc from A to B, not passing through C, measures 50 degrees. Select all the true statements. All right, angle BCA. BCA is the inscribed angle, so it is going to be half of 50 degrees. The inscribed angle is half the central angle, so it's going to be 25 degrees. Angle BOA measures 50 degrees. BOA is the central angle with its vertex at the center, and it does measure 50 degrees. The arc from B to C passing through A measures 180 degrees. So that would be if you start at B and measure the arc all the way to C, you could see it looks like it's 180 degrees, but that chord does not go through the center, point O, so it is not 180 degrees. Angle CBO and CAO are congruent. Well, they don't share the same endpoints, so that's not true. Question 5. Chords AC and DB intersect at point E. Match each angle to its congruent angle. Angle ADB. ADB is an inscribed angle. It would be the same as BCA. BCA, that is also an inscribed angle with the same endpoints. BCA is the same as ACB. ACB. Angle DEA. Angle DEA is going to be is a vertical angle with CEB, CEB or BEC, CEB. They are vertical angles. And the last one is CAD. CAD is an inscribed angle with points C and D as endpoints. So is CBD. CBD, which is the same as DBC. CBD or DBC. Question 6. The image shows a circle with diameters AC and BD. Complete the following to prove that chords BC and AD not drawn are congruent. Angles AED, angle AED, that's a central angle, and BEC, also a central angle, are congruent because they're vertical angles. They're vertical angles. Segments AE, that's a radius, BE, DE, and EC are all congruent because they are radii of the same circle. Radii, that's the plural of radius. So triangles AED and BEC are congruent by. Okay, so if you have the vertical angles are congruent and these two sides are congruent to these two sides, that would be side angle side. Are congruent by the side angle side triangle congruence theorem. Now AD and BC are congruent because they are corresponding parts of congruent triangles. Corresponding parts of congruent triangles. Question 7. The line represented by y plus 3 equals negative 3 times x plus 6 is transformed by the rule x comma y, then negative x comma negative y. What is the slope of the image? All right, let's go ahead and type that. That was y plus 3 equals, what was it, negative 3 times x plus 6. Turn on I'm going to turn on the grid and the axes to see the line. You can see it contains the point -7, 0. And you can see that point right there is on the line. It also contains the point -5, -6. All right, you can see the red dot is on the line. So if we make the x and the y values their opposite, the opposite of -7, 0 is +7, 0. And the opposite of -5, -6 is 5, 6. All right, so you can see the line has the same slope, which is down 3, right 1, down 3, right 1. So it's -3.